Hello there, and welcome to Lecture 6, where we will have a look at the Rigidbody2D and Colliders2D component, okay? Double-click on the Unity icon to open it up. With your scene empty, create a new empty game object using the key combination Ctrl-Shift-N, okay? Change its name to Zombie, and place it at the 0, 0, 0 position as always. Add a new rendering sprite render component and drag and drop your zombie textures to the sprite property, okay? Fine. Now we're going to add here a ground. Freight, look on the internet for some ground sprite. I found this one very interesting for our game. Well, for our purpose. This is not our final game, okay? So give it a descriptive name. For example, ground inside the 2D game tutorial, assets and textures, okay? Call it ground and save it. Now return to Unity, and here is our ground, okay? So create a new game object and place it at the 0, 0, 0 position. Add the new rendering, the sprite render component, and drag and drop the ground texture onto the sprite property, okay? And scale it on the x-axis and on the y-axis. Okay, this is not looking very good. That our game will be much better than this, so don't worry. Okay, this is just for demonstration purposes. Fine, let's start by introducing the Physics 2D rigid body component. Okay, in this lesson, in this lecture, we're going to take a look at the rigid body 2D component and all of those collider 2D components. Okay, we're not to take a look at those joined 2D components. Okay, because we're not going to use them in our game, in our final game. Okay, let's begin with the rigid body 2D component. If you click it, then you will have here some properties inside your zombie game object. Okay, the mass, as you might expect, this is the mass of your zombie. Okay, you can select any value you want. Okay, for example, set it to 60 kilograms. Okay, this is the mass of our zombie. Okay, now we have the linear drag and the angular drag. Well, the drag is the tendency of an object to slow down due to friction with air or water. Okay, the linear drag applies to positional movement, whereas the angular drag applies to the rotational movement. Okay, you can change those values. How our game object will be slowed down by any forces acting upon it. Okay, now the gravity scale, how much the gravity will affect our game object. Okay, as you may already know, the gravity intensity is of minus 9.81 meters per second square on the y-axis. Okay, so to change its value, go to Edit, Project Settings, Physics 2D, and inside the inspector view, this panel appears. Now, you can change the value of the gravity, okay, in the x-axis and in the y-axis. Okay, leave it as it is. Okay, so 0 in the x-axis, there is no gravity along this axis, and minus 9.81 meters per second square. So the gravity is acting in this direction. Okay, fine. So return to the zombie game object. If you put gravity scale to 1, then the gravity will affect our zombie with an intensity of 1 by 9.81. Okay, if I put this to 0.5, then the gravity intensity affecting on our zombie will be of 0.5 by 9.81. Okay, leave it at 1. Fixed angle. If you select this option, your zombie will not be able to rotate during the play, okay, during the game. It's kinematic. If this option is enabled, then the zombie game object will not be affected by any forces or by any collisions, right? And if I deselect it, then the zombie game object will be a dynamic object. That is, any forces or any collisions will have an effect on our game object. We'll not take a look at interpolate, sleeping mode, or collision detection in this course, but you can find what they do in the scripting, in the Unity 3D scripting reference. Well, that's it for Rigidbody. Okay, if I press the play button, you can see as the press the play button. You can see as the zombie will go down forever. Okay, it didn't detect the ground. It didn't detect the presence of the ground, so the zombie didn't stop at here. Why? This is because we need something called colliders, okay, to detect collisions. Okay, when the zombie touches the ground, we want it to stop. That is, we want to add a collider to the zombie and to this game of change this to ground. Okay, this name is ground. We want to add a collider to the zombie and to the ground, so that when those colliders come into contact, those two reach an equilibrium position. Okay. For example, go to zombie and add a physics 2D box collider. Okay, as you can see here, a green box appears around the zombie game object. You can change that green box using the size property of the box collider 2D component and its position, okay, the X and the Y in the Y axis. Okay, so place it at some realistic point, change its size, the X and the Y position, try to fit it to the zombie shape as much as you can to get something realistic. I think that will do the job. But now we need another collider to the ground, okay? So that when this collider come into contact with the ground collider, then they will reach an equilibrium position. So go to the ground game object, add a new component, physics 2D and box collider. As you can see here, here's the collider, okay? Fine. So if I press the play button, the zombie will stop at the ground level. Okay, that's good. If I, for example, turn this object a little bit like this and press the play button, then an equilibrium position is reached again. Okay, that's what I mean by equilibrium position. Okay, so those game objects will interact like if they were real physics components, okay, in the real world. Fine, change back this angle to 0. Okay, as you can see here, this collision is not realistic. We would expect the zombie to bounce a little bit when it touches the ground. To do this, we need to add a new physics material to the ground box collider 2D component. Okay, to do this, right-click on Assets, create folder, and call it Physics Materials. And right-click in this empty zone and add a new Physics 2D component. Physics 2D material. Okay, click it and name it with a descriptive name. Okay, for example, grass. Fine. We're going to try to reproduce the grass here, the grass behavior, using two options, okay, the friction option, or the friction property, and the bounciness property. This is the property we're looking for. It must be some value between 0 and 1. If you set, well, you must drag and drop this grass material to the material property inside this box collider 2D component. Okay, now it is added, as you can see here. Okay, we placed here 0, so if we play the scene, it will not bounce. And if we put this to 1 and press the play button, it will bounce forever. Okay, those are the two extremes. Okay, extremely behavior. If we put this to 0, there will be no bounce, and if we put this to 1, it will bounce forever, because there would be no loss of energy here between the zombie and the ground game objects. And if we play to some value between 0 and 1, for example 0.4, and press the play button, it will bounce a little bit and then stop. Okay, this is the most logical behavior. Okay, try playing with those values. Okay, with this value. Okay, the friction is not affecting us because the zombie game object is not moving tangentially to the surface. Okay, as for example a car. How much friction does this ground have? This is controlled by the friction property. Okay, leave it as it is. Okay, for example, bouncing it to 0.37, it will bounce like this. Okay, try playing with these values. Don't be afraid of getting to know with the properties of Unity 3D. Okay, fine. I think that's it for the box collider. We can remove this component and add the new physics 2D circle collider, edge collider, or polygon collider. Okay, they all work in the same way. The only difference between those four colliders is the shape of the collider. Okay, for example, add a circle collider to our zombie. Okay, as you can see here, this is no longer a square, but it is now a circle. So for example, if I rotate here like this and press the play button, it will not just stop the ground, but it will start to rotate. Okay, this is not the logical behavior. Okay, so in this case we would not like to use the circle collider, right? You can remove this component. The most realistic component you can see here is the polygon component. Okay, if you click it, you can see as this collider fits perfectly on the zombie texture. Okay, not like the circle or the box collider. Okay, so for example, if you wanted to change any of those points, you can press the shift key on your keyboard, and with that key pressed, click on any of those green dots appearing. Okay, for example, I can click and drag this point. Remember that you must have the shift key pressed, okay, to make it more realistic. If instead pressing the shift button, you press the control button, then those points will not be green, but they will be in red color. That means that if you click, they will delete. Okay, pressing the control key. Okay, and that way we can key some control points we don't want. Okay, and with the shift key we can modify them their position. Okay, fine. So for example, if I set this angle to 0 and press the play button, the zombie game object will rotate. Okay, if we don't want a game object to rotate during the play, we can set this fixed angle property to true. Okay, and now if we play the game, it will not rotate. Okay, for example, you could rotate it like this. This foot of the zombie. Well, if you go to Gizmo and deselect the 3D Gizmo, this camera icon will no longer annoy you. Okay, you can change it back. Okay, or even you can change its size. Okay, I will set it to something like this, and then deselect it. Okay, when the zombie falls to the ground, this foot will go through the ground or through the terrain. This is because the collider is not around this foot. Okay, play this scene. As you can see here. The foot is through the ground. Okay. Sorry. You can see it. You can see it here as well. Okay. So I think that's it for colliders and Rigidbody2D component. Try playing around with those components. Okay. before going to lecture 7 and so on. Okay, in lecture 7 we will cover the script behavior component. So that's it for this lecture. Thank you for watching and see you in the next video.